Today we're going to be talking about refraction as it pertains to thin lenses. Now everybody uses the lens every day because we have a natural lens in our eye. But anybody who has corrective lenses, glasses, contacts, that's another type of lens. We have lenses in telescopes, we have lenses in the projector, on the ceiling, we have lenses all over the place. And so we're going to talk about how they affect light and how they produce images. Now there are two main types of lenses we're going to talk about. A converging lens is the first type. Now you'll see in this diagram here, it'll say a convex lens. Now the reason why I'm crossing that out, I really would like you to understand them as converging lenses. And the big reason why is, yes, it has that convex shape that we remember with our mirror, but I like to call lenses by how they affect light. Now this converging lens causes parallel lines of light to all converge at one point. And of course, we call that the focal point because it focuses the light to that point. In your book, we may refer to it as a convex shape, but it's a converging lens. I really want you to kind of stick with that terminology. So it converges all the light to one point. Now, as we learned in the lab on Wednesday and discussed that yesterday, that as light goes from air to another medium such as glass, it slows down, which causes it to bend. And so we're just using that principle in the shape of this lens to actually bend all the light towards one point. And so focus that point, then it spreads out again. A lot like our concave mirror. Now the diverging lens does the opposite. It spreads light out. And again, it's because of the angle at which it comes in and the fact that it's slowing down, that changes the angle. And so we have the initial angle, we have the new angle, and that spreads light out. Now with the diverging lens though, if we follow the parallel lines after they're refracted, after they're bent, we follow those backwards, they go to a point. And now that is our focal point. So a converging lens, it's easy to figure out what the focal point is. With a diverging lens, in this case you see somebody calling it negative, it's because we have to follow the refracted lines back. And typically we'll say it has a negative focal length, because it's on the other side. Now, for image formation, we have our first two phrases from before. Number one, in through the focus, out parallel. Number two, in parallel, out through the focus. And here's our third one, through the center. Now this actually makes it simple because really you only need two lines to cross to figure out where the image will form. So if you just go off of those two, that works. Now each lens has two foci since light can pass through either side. You can only use each focus once as far as these phrases are concerned, so you need to remember how it affects parallel light. Does it spread it out or does it converge it? So when you say in through the focus, are you talking about the initial focus or are you talking about the second focus? And the same thing without parallel. So lens equation. Now I know this might be a tricky one for you, so let's pay attention. 1 over P plus 1 over Q equals 1 over F. And guess what? The P, the Q, the F, they're all the same as before. So P is the object location, Q is the image location, F is the focal length. And then of course H prime over H is equal to negative Q over P, which is equal to M, which is our magnification. So hey, guess what? That's all the same. Same as a mirror. So that's why we like this. Now, a couple things to remember though. Object location is going to be positive when it's in front of the lens, negative on the other side. Image location is positive on the other side of the lens, negative when it's on the same side as the object. Height. H prime is positive when it's upright, negative when it's inverted, and the focus is the other thing. For a converging lens, the focus is positive. For a diverging lens, the focus is negative. So remember that sign notation, but otherwise it's the same exact equations we've used before. So let's look at this for a second. For a converging lens, we go in parallel, out through the focus. So here's that focal point right there. Here's the other focal point. You add those. So in parallel, out through the focus. In through the focus, and we'll just act as if it's acting in the center. It goes out parallel. And then through the center. You can see how it goes right through the center. Let's just do this here. That's P and that's Q. Just use an image with different notation on it. So Don't worry about the other words. So this is our object, this is our image, where they cross, and again, if it passes through the center, it just keeps going through. So the bottom here will place on the center line, and we know the bottom's going to be on that. So where's the top of our image? So in this case here, remember that light passes through the lens. It doesn't seem that different than what we did before. So for now, it's just passing through, so getting reflected. So you see the first line here, use this focus. The second one, use the other. They can't both go through that. And I know that a parallel line coming into a converging lens goes and gets focused. So I know that it has to use this one, not that one. Now for a diverging lens, it's a little different. Think back to our convex for a second. So a parallel line comes in, it goes out from the focus. Remember, parallel lines of light with a diverging get spread out. So here we go. Let's just draw in the focal points for a second. Those are our foci. I'm going to get rid of that. This is our object. And let's get rid of that. That's our image. There we go. So, in parallel, out from the focus. In through the focus, stop in the middle, out parallel. And the third through the center. Now, none of the refracted lines are going to cross, so we have to follow them backwards. So follow the refracted backwards. And so this would be our image right there. So it's smaller, and it's between the focus and that. And again, with the diverging lens, pretty much there is one situation. Converging lens, there are multiple situations. So, with this, tricky thing I know, remember, it's going to go in parallel, out through the focus, out from the focus. See, I can't go through here. Well, that's what a converging lens does. This is a diverging. It spreads light out. It spreads the parallel lines out, so it has to come from that focus. And then this one tries to go through the focus, but I know it's going to get bent. It's going to get refracted in the middle, so it comes out parallel, and the other one just goes through the center. Now, just to kind of see this in a little bit more depth, here we have a nice little animation for that. So we have our converging lens here, and there are different situations with the lenses. So let's just see what happens. So here are the dots for the focal points. On the left here is the object. On the right here is the image. So if I move my object well past the focal point, you can see that pretty much the image I get is on the other side. Now in this case here is a real image because I can put a screen there and capture it. A converging lens is the only one that can produce a real image, just like a concave mirror. So I can put a screen here and get a image on it. Now as the object comes closer and closer to the focus, the image gets bigger and bigger and bigger and even gets magnified. Now here's the interesting thing. At the focal point, now if I place this directly at the focal point, look at these three lines. They are parallel to each other, which means that they will never meet. Now I want you to think about a lighthouse for a second, or just any flashlight that has a very narrow beam. What this does is it's sending all the light from one point. It's going to be all going out parallel. It's going to be a beam of light. They'll never cross. This is how a lighthouse works. This is how a lighthouse sends that perfect beam of light across the sky, or a tower at an airport. So at the focus, I get no image, just like the concave mirror, because these lines don't cross. Move inside the focus, now I get my virtual image. Now you can see in this case here, the green lines are following the refracted light backwards to where they cross. And you see I have this big image forming here. That's a virtual image because, well, I can't put a screen back here to capture it because light's going to pass through. So there's no actual light, it's just going to appear to come from there. And so it's very big when I'm close to the focus, and it gets smaller as I get closer to the mirror, closer to the lens, sorry. So those are the different stages for a converging lens. A diverging lens is always virtual, always smaller, always upright. A converging lens, you can see we flip sometimes, we magnify sometimes, and we get no image at the focus, just like the concave mirror, and then we get virtual inside of that, and we can get magnified. So that is